everyone. Let's now study electric field due to an electric dipole at a point on the equatorial plane. So let's take a dipole. A dipole consists of two charges, negative charge and a positive charge. So this is the negative charge minus Q here. Then we'll take a positive charge. The positive charge here is plus Q. There's a distance between them. Okay, for that we'll draw the axis here like this. Okay, and let this be the midpoint of the axis. Okay, we'll name this as O, and then the distances from O to Q we'll mark it as small a, and this distance we'll mark it as small a also. Okay, then we have to take a point on the thing, okay, on the equatorial plane. So this point, okay, let's take at this point here. This point will be on the equatorial plane. Okay, so you can imagine there's a plane here, see it in the book. Okay, there's a small plane like this way, and then we'll take a point here. Okay, I'll draw the plane a little later. Now we must see what is the electric field at this point. Okay, for that I'll name this point as A, this as B, and this one as C. Now let's see the electric fields due to the positive charge. Okay, so for positive charge, electric field will go outwards like this way. So this is the electric field due to the positive charge, E plus. And then the electric field due to the negative charge will travel inwards, so like this way, towards the negative charge. Okay, now we can see this is the electric field due to the negative charge. Okay, these two things must add to each other. Okay, we can use vectorial addition. Okay, so let's do that and see. Now we can add them using vectors. You can use a parallelogram law like this way. You can construct a parallelogram, and then let's see the net electric field. The net electric field will travel in this direction like this way. So this will be the net electric field or the total electric field, E total. Okay, these are all vectors. Okay, so the net electric field travels this way. Now we must see one more thing, the distance here. This distance between O and C, okay, this distance we'll take it as R. This distance taken as R. Then let's take a dipole moment here. Okay, the dipole moment starts from negative charge and goes to the positive charge. So dipole moment goes this way. This is the direction of the dipole moment P. Okay, P vector. And then let's take the angles also now. So let's see the angles here. Let me mark this angle as theta. This angle is theta. This angle is also is theta. Okay. Now let's see what is the total electric field at this point C here. Okay. So let me take the point C. Okay. So this is the electric field due to the positive charge. We'll draw it here in the color. So electric field due to the positive charge, and then so I'll write it here, electric field due to the positive charge, and then electric field due to the negative charge like this way, electric field due to the negative charge. Okay, now you must see that electric field, first will take electric field due to positive charge, that you can resolve in two components, horizontal and vertical component. Okay, so this will be the horizontal component here, electric field due to positive charge, horizontal component, and this angle is theta. Okay, horizontal component will be electric field due to positive charge cos theta, and the vertical component you see, that will be electric field due to the positive charge sin theta. Okay, now these are vectors. Okay, Let's similarly take the negative charge here. This is the negative charge, electric field due to negative charge. This angle is theta, and this will be in two components again. Okay, this is the horizontal component, E minus cos theta vector, and this will be the vertical component here, that is E minus sin theta. Okay, you can see that E plus sin theta, E minus sin theta will cancel each other. Okay, these two things will cancel each other, but these two things will add to each other. Cos theta, E plus cos theta, and E minus cos theta will add to each other. So let's see that now. So we can see the total electric field E total is given by, you have to add these two. So but you see the dipole moment goes from left to right, but these two are against dipole moment, so you must write minus p vector. Okay, let's see this now. So we have here magnitude of E vector cos E plus vector cos theta, and you see dipole moment, it's against dipole moment, so you write here dipole moment p, and because it's against it you must write minus sign. Then again write a minus sign to show for the negative charge also. We have here magnitude of E minus, this is E minus the electric field with negative charge cos theta, and then p vector or p cap. Okay, so let this be equation number 1. Now we must find what is the electric field due to the positive charge here. Okay, so let me write this down. Electric field due to the positive charge E plus. Okay, that will, or you must find the magnitude of this also. You must find the magnitudes. That's equal to the electric field due to the negative charge. That will be equal to, we have the formula for electric field, that is 1 by 4. I'll write this side. Okay, electric field formula, that is E is equal to 1 by 4 pi epsilon naught into Q by R square. Our aim is to find what is this R square here. Here, so let's see this now. 1 by 4 pi epsilon naught Q by, okay, now we'll take this triangle here. You see this triangle, I'll take it here, and I'll draw this triangle here. Okay, we'll draw this triangle. Let's see what is the distance here. This is A, this will be R, and what is this? We use a Pythagoras theorem. The square of the hypotenuse is equal to sum of the squares of the other two sides. Okay, so let me write this also down. Okay, here I'll draw it. So use a Pythagoras theorem, that is the hypotenuse square is equal to the sum of the squares of the other two sides, that is r square plus a square. So what will be the hypotenuse equal to? It is equal to square root. Okay, square root of r square plus a square. That means we can write power half also. So r square plus a square power half. Okay, so this will be the hypotenuse, that is r square plus a square power half here. Okay, so this is the distance between the negative charge and C, or between the positive charge and C. So that I'll write it here. Okay, and remember in this formula we have this r square. Okay, so this is different from this one. Okay, this r square. So let's see this now. That will be r square plus a square power half, and you see in the formula there's a square also. That square term I'll write it here outside. Okay, now this is power half and this is square, so these two terms will cancel each other. So what we have is here, so this is power half and this is square, these terms will cancel each other. So what we have is 1 by 4 pi epsilon naught into Q by r square plus a squared here. Okay, there's no other terms here. Okay, then let's now come to the total electric field. Okay, we'll take this equation 1, we'll substitute these values in equation 1. Okay, let's see this now. So substitute in equation 1. Okay, let's substitute and see what we get. So total electric field E total will be equal to minus of, okay, this one e plus cos theta, that value I'll write here, this one, okay, this value I'll write down. So that is 1 by 4 pi epsilon naught into q by r square plus a squared, okay, and then we have this cos theta and p vector, p cap. So I'll write this cos theta, okay, I'll write it here again, cos theta p cap, okay, minus this again second term, e minus term, again we'll have to write this one, that will be 1 by 4 pi epsilon naught q by r square plus a square cos theta into p cap. Okay, you can see these are two like terms only, you can add them. Okay, this is minus here and this also minus here, so you can add, it will be minus 2. Okay, let me add this and write down now. So here we'll have 1 by, or minus here, minus 1 by 4 pi epsilon naught, and then this is q and this also q, so write as 2q cos theta by this term, that is r square plus a squared, okay, into p cap. Now we must see what's meant by this cos theta, what's the value of cos theta. Okay, let's study that now. Okay, let's see how to find the value of cos theta. Again I'll take the triangle here like this. See, we already drawn it here. Okay, that will be a, this is r, and this will be r square plus a square power half. Okay, now this angle is theta. Okay, let's see from this what will be cos theta equal to. So cos theta is equal to adjacent side by hypotenuse, so a by this value, so a by r square plus a squared power half. Okay, so let me take that and write it instead of cos theta. So what we have is minus 1 by 4 pi epsilon naught 2q by r square plus a squared, instead of cos theta write this value. Okay, it will be into a by, okay, now I'll open a bracket here, this will put a bracket here, r square plus a squared power half. This is power 1, if nothing is there it is power 1. So let's see what's 1 plus 1 by 2. Okay, this one I'll write here this side, so 1 plus, and then p cap also is there. Now 1 plus 1 by 2, this means 1 by 1, so common denominator is 2, cross multiply 2 plus 1, that will be 3 by 2, so this will become power 3 by 2. Okay, let me write next. So I'll write it here, that will be minus 1 by 4 pi epsilon naught into this 2q, write as it is 2q a, and then p vector, p cap also right on top. Okay, then divided by this value, that will be r square plus a squared power 3 by 2. Okay, we found it now, so power 3 by 2. Okay, now let's take a condition here. Okay, if this r, now let's take condition, if this r is much more bigger than a, then we can neglect a squared. So if r is very much bigger than a, neglect a squared. Okay, if we neglect a squared, let's see what happens. Okay, so that we'll write that side. Okay, so let's see, if you neglect a square what we get. So we get here equal to 1 by, you can see this, yes, so 1 by 4 pi epsilon naught into this one 2qa p cap divided by r square power 3 by 2. See, we have neglected the a square, so we get r square power 3 by 2, and then minus sign is also there, no? Okay, you write a minus sign here. Okay, so this value will be getting. Then now you see this is square, you can see this is square term and this is power half, so the half term, that is this one, and the square term will cancel. Okay, so what we left with, we left with r power 3. So we get here the electric field, the total electric field E total will be equal to minus 1 by 4 pi epsilon naught into, and then we can see this 2qap is there, no? That we can write as p vector. Okay, p vector, we learned that now dipole moment is equal to 2q a and p cap. Okay, so instead of writing this term, we can write as p vector. So we write as p vector divided by r cube. Okay, this is r cube. So this is the value for the total electric field at a point on the equatorial plane of the electric dipole. Okay, now let us see some more terms here. Okay, but before that, okay, we'll see what's meant by the equatorial plane. We'll go back to the picture one more time. Now you see the picture here. Okay, see this part, this point C, it's, they say it's on the equatorial plane, so you can imagine a plane like this way. Okay, so this point C is on the equatorial plane. Okay, let's see some important notes about this thing. Okay, the first thing to notice that the dipole moment here, you see for the equatorial plane it is 1 by 4 pi epsilon into p vector by r cube, but if you see for actual plane it will become 2p. Okay, so the electric field in the actual plane, that is on the actual plane, was, it is like this way. Okay, the two charges were there and this was a point here, so this will be 2 times greater than that of the equatorial plane. Okay, next one, you can see for actual plane the electric field will be in the same direction but as a dipole moment, but for the equatorial plane, we saw, now we have studied about the equatorial plane like this way, the electric field was pointing away from the dipole moment or opposite to the dipole moment. Okay, this is one thing you must note. Okay, then the second one, the electric field, they say it varies as the cube of the distance here. Okay, so electric field is inversely proportional to the cube of the distance. As the distance increases, electric field will decrease dramatically. Next one, they say, so we have this two charges now, we see have this equation, you can see 2qap. Okay, so this equation works only if the electric fields or if the charges there are very close to each other. Okay, very close by, so the distance here, that is we saw 2a, we can neglect that also. Okay, so only then the equation will work and it's for any kind of value of r. Okay, so these are two important things, that's electric field due to an electric dipole at a point on the axial plane and at a point on the equatorial plane.